So today we'll focus our attention on the rule, the product and quotient rule of derivative. So the basic rules help us find derivative of simple functions. We know that. Okay, in our previous section, we actually found derivative of many different functions, but very basic functions. But what happens if the function gets more complicated? Okay, in this sections, we'll focus our attention on those type of situations. Okay, for example, as you can see here, example 1, find the derivative of the function f of x equals 4x cubed minus 11 times x plus 3. So one way of doing this is, what you can do is, you can multiply these two factors, which will give you 4x to the power 4 plus, if you simplify it, you're going to get 12x cubed minus 11x minus 33. So then you can find derivative, which is 16x cubed, right, using the power rule, plus 36x squared minus 11. And derivative of 33 is 0 because that's the constant. So we can do this way. But now suppose you are given a function like this. Okay, f of x is 4x to the power 5 plus x cubed minus 1.5x squared minus 11 times x to the power 7 minus 7.25x to the power 5 plus 120x plus 3. Now multiplying this, not fun thing, right? It's boring, it's a lot of work. We don't want to do that. So what we can do instead is we can actually apply this product rule of derivative and solve it. We'll do that in a minute, okay? Instead of multiplying, we don't multiply. We don't need to multiply this because it's too much work, you know? We know how to multiply in high school. No need to multiply to find derivative. We use product rule. Okay, so that's one of the goals for today's lesson, product rule. Now the proof, we don't do the proof here, we just apply the formula. So the product rule is this: d over dx of f of x times g of x equals f prime of x times g of x plus f of x times g prime of x. Meaning when two functions are multiplied, the derivative will be, you just do the derivative one at a time. So for example, if you want to find the derivative of f of x times g of x, what's that saying is basically you copy the same thing twice, f of x g of x plus f of x g of x. Just copy the same thing twice and do the derivative one at a time. Okay, so you can do this derivative for f first or g first, doesn't matter, this one, or you can do this as well, f of x g of x. You can actually find the derivative for g function first and then f function first, doesn't matter. Okay, so that's what we do. You know how to copy it, just copy the both functions at the same time, twice, and then you just find the derivative one at a time. That's it, that's the formula. To write f of x g of x is a lot of work, so to easily remember and to make it a little short, you can actually use this as uv. Okay, for f of x you can use that u as v, g of x as v. Then now derivative of u dot v can be written as u prime of v plus u v prime. Okay, so that's the formula we'll use. Now let's look at example 1, part A. So given, let me just copy the function as it is. Given the function as 3x squared minus 1, 7 plus 2x cubed. So you see, you can assume that this one is your u, this one is your v. Now the derivative will be, the formula is product rule, because we see that there are two functions multiplied. So the product rule is f prime of x equals u prime uv, just copy uv twice, uv plus uv, and derivative one at a time. Okay, so that means we need to find the derivative of this. So derivative of 3x squared minus 1. I think you can tell me what is the derivative of that. So derivative of 3x squared minus 1, what is that? You know that that will be 6x minus 0. Derivative of 3x squared is 6x, derivative of 1 is 0, and copy v as it is, because v does not have derivative. So just copy as it is, which is 7 plus 2x cubed, plus copy u, because u doesn't have derivative, you just copy that 3x squared minus 1, and find the derivative of v, because here you see that v prime, so which is 7, derivative of 7 is 0, plus derivative of 2x cubed is 6x squared. So what we got here is that 7x times 7 plus 2x cubed plus 3x squared minus 1 times 6x squared. So you can leave it there, but since this one is pretty, easy, easy expression, so maybe you can simplify further. So let us simplify it. So you will get 42. Oh, by the way, I can see that 6x I can take common in both. I'll get 6x common, so the remaining is 7 plus 2x cubed here, plus 3x squared minus 1 times x there. So when you simplify, you're going to get 6x times, that will be, can you tell me if you simplify, how much do you get? 5x cubed minus x plus 7. Okay, if you simplify it, you're going to get this much. All right, any questions so far? Now let's move part B. I just want to copy that function. F of x is, you have already seen that function before, but I want to copy it here. 4x to the power 5 plus x cubed minus 1.5x squared minus 11. And then x power 7 minus 7.25x to the power 5 plus 120x plus. Okay guys, now we know the formula. As you can see, the first term here, the whole term, consider the whole term as u, and your second, the whole term will be v, okay, this factor. So this first factor, let us assume that, let us denote that by u, and the second factor, let us denote that by v. Now we know the formula. Clearly we have to use the product rule here. The product rule is f prime of x is uv. We just copy uv twice. Everybody know how to copy that. It's simple. Now we do the derivative. So first we find the derivative of u, and we leave v as it is. We do nothing with the v. So if you find the derivative for u, you're going to get 5 times 4 is 20x to the power 4 plus 3x squared minus 3x minus 0, and copy v, which is x to the power 7 minus 7.25 x to the power 5 plus 120x plus 3. and plus copy u. So copy u because u doesn't have derivative there. So u is 4x to the power 5 plus x cubed minus 1.5x squared minus 11. And then find the derivative for v. So derivative of v will be 7x to the power 6 minus, how much is that? 7 times 7.25 times 5. Is that 36.25? X to the power 4 plus 120 plus 0. I don't have to write that 0. Okay, plus 120. That's it. If you want, you can multiply, you can simplify it, but that simplification is just the high school stuff. So we don't do it here. Our goal is to find the derivative and we are done. If you want, you can simplify, okay? Simplify just for fun. But we don't need, you don't need to. Okay, just keep that in mind. If it is a simple expression like in example 1, maybe you may want to simplify a little bit, but when you have this kind of expression, then that's just ugly, so you don't need to do it. Okay, just leave it there. That is all about product rule. Okay, yes, you don't need to simplify unless the question tells you to simplify in the exam. But if you are if you are given these kind of expression and if you are asked to simplify, that's not going to happen. Okay, like in example A. Okay, so in example A, if this question is given in the exam, then you may require to simplify a little, up to this point, but in general, no. That is all about product rule. We are done objective number 1. So the objective number 2 is the quotient rule. So let us focus our attention on quotient rule. So quotient rule means, quotient means the division. Okay, when two functions are divided, then how do we find the derivative? That's the question. Okay, so let's look at this part A. Here is the formula. The formula is that when you have two functions divided, you can use this as f of x over g of x, but for simplicity I use u and v. Okay, so what is the formula? Well, the formula is this. You copy the same thing twice again here also, but this time negative because we are doing the division, okay, not multiplication. In case of multiplication, we have to write the plus sign, but in case of division, minus. And the same thing, derivative one at a time. So derivative of this, u, and then after that, derivative of v. But one more thing you need to remember is that you must divide that by v square. Okay, so it's not difficult to memorize. Guys, you just copy the same thing twice and minus in between, and as in the example of product rule, you just do the derivative one at a time, and don't forget to divide the whole thing by v squared for product rule. The proof is not required, but those who really want to see the proof, maybe I'll give you the proof in my lecture note. Okay, you can just have a look. For exam point of view, proof is not required for this course. All right, guys, now that's the formula, and we're gonna use this. Part A. So we are given f of x is 3x squared minus 1 over 7 plus 2x cubed. Now remember, this is in the form of u over v, okay? So the first part you can consider that as u, and the second part you denote that by v. So we have two functions, okay, two polynomial functions divided. So we're gonna use the product quotient rule. Quotient means division rule, okay? Short, the easy word for that is division rule, when two functions are divided. Okay, now using the formula, we know that f prime of x is quotient rule is ub, just copy the same thing twice, ub minus at this time and derivative one at a time. But remember, you must find the derivative of the numerator first, okay? In case of product rule, you can actually switch. In case of product rule, you can have ub plus ub, this one, or you can have ub plus ub, this one. It doesn't matter because of the plus sign. 2 plus 3 or 3 plus 2 is the same thing. But in case of quotient rule, it's minus. So 2 minus 3 and 3 minus 2 are different things. So please pay attention to that, okay? In the exam, you know, sometimes people just messed up with the formula. So keep that in mind. You always need to do the derivative of the numerator first, and then derivative of the denominator in the second part, over b squared. So this is the formula. Now let's find that. So equals u prime. So u means this. So the derivative is 6x, because 3 times 2 is 6x minus 0. I don't have to write that. Copy b, which is 7 plus 2x cubed, minus u. Copy u, which is 3x squared minus 1. And derivative of the bottom part v, which is 6x squared. So you can take that common if you want, because this is simple, so you may want to simplify it a little further, okay? So if you simplify it, you can take 6x common, remaining 7 plus 2x cubed, and minus, you're gonna get 3x squared minus 1 times x. So which gives me 6x, and then this, if you simplify it, you're gonna get minus x cubed plus x plus 7. I forgot to write v square, guys. Okay, don't forget to write the v square. So v square means this 7 plus 2x cubed squared. So v square I'll write there. Okay, just give me 1 second. So the v square is 7 plus 2x cubed squared. So your final answer is going to be 6x times minus x cubed plus x plus 7 over 7 plus 2x cubed squared. All right. Now, at this time, you may want to try part B. Guys, everyone, please try part B on your own. Let's continue this part B. Let me do it quickly for those who still, you know, are working on it. So, like I said earlier, this is u over v. It's actually the quotient rule that we're going to use, because it's in the form of u over v. Two functions are divided. So, quotient rule, the quotient rule tells us ub minus ub over v squared. Remember, you can write, instead of ub, you can write f of x times g of x. The reason I'm writing ub is it's pretty easy, you know, to write down f of x takes a lot of time, right? So this one is easier for me, and I think it's easier for you as well. So we need to find the derivative on the top, which is 2x minus 3, derivative of the top part, and copy the bottom part, because just copy the v as it is, x minus 1, and minus copy u, which is x squared minus 3x, and then find the derivative on the bottom part, which is 1 over v squared. So that's going to give me x minus 1 squared. So this is pretty simple. You can simplify it. It's not a big deal. So on the top, you can, I think you can get x squared minus 2x plus 3 if you simplify that over x minus 1 squared. So this would be your answer. You can simplify x minus 1 whole square, but I think this one is even looks better, so you can just leave it like that. If you can factorize on the numerator and if you can cancel it, you can do that further, but it looks like we can't do it. Okay, so now let's work on part C. Now, part C, one way is to simplify first, okay? Simplify the top part, multiply that, and then use the quotient rule. But you don't have to do that, okay? You don't have to do, but if you want, you can do that. I think that will simplify life. I mean, that will make life a little easy. We can do both ways, okay? First, let us simplify the top part a little bit further, and if you multiply, what are you gonna get? I believe you get 2x to the power 4 minus 6x cubed plus 5x squared minus 15x over 3x squared minus x. That's one way of doing. So now you have u over v. U means the numerator and v means the denominator, and you can find the derivative.
Hi, Professor.
Yes.
Can
Okay, so you can actually cancel that x minus 3 term by taking the common, here and here. Maybe we can do that later. Let's do this way first, because sometimes, the term are not cancelable. So how do you do it? So let's try that without canceling, but you can always do that by canceling those terms. So now you're going to get, the formula is this. So u prime, so you will get 8x to the power 3 minus 18x squared plus 10x minus 15, and copy v, which is 3x squared minus x, minus u. Your u is 2x to the power 4 minus 6x cubed plus 5x squared minus 15x. And then you need to find the derivative of v, which will be 6x minus 1 over 3x squared minus x squared. So you are done. If you want to simplify just for fun, go for it. I don't have any problem, but you don't have to simplify it. Okay, this is a little lengthy expression, so you don't need to simplify. Just leave it like that. Another way of doing this, said method 1. Now let us do the same problem by another method. I just want to copy it. Part C, f of x is x minus 3, 2x cubed plus 5x over 3x squared minus x. Okay, so first you see this one is u over v form. It's quotient rule, definitely we have to use. So the quotient rule will be uv minus uv over v squared prime prime. So we know this formula. Now, u prime means we need to find the derivative of x minus 3, 2x cubed plus 5x prime, and copy v. V is 3x squared minus x, minus copy u, which is x minus 3, 2x cubed plus 5x, and derivative of v, which is 3x squared minus x prime, over v squared is 3x squared minus x squared. Now you see you need to use the product rule here now. First quotient rule, and then product rule. Here product rule. Okay, so let us find the derivative of that using the product rule here, and then we just copy and paste. Okay, so we want to find x minus 3 and 2x cubed plus 5x. We need to find the derivative of this. So that means this is your u. You can suppose that as u, this one as v. So the product rule is uv plus uv prime prime. You know that. Derivative is 1, copy v, 2x cubed plus 5x plus copy u, which is x minus 3, and derivative of v, which is 6x squared plus 5. So you may want to simplify it if you like. That's going to be 2x cubed plus 5x plus 6x cubed plus 5x minus 18x squared minus 15. So that will be 8x cubed and minus 18x squared plus 10x minus 15. So we just copy that as it is. So that's going to give me 18x cubed minus 18x squared plus 10x minus 15, this part, and then you have 3x squared minus x there, minus copy this first x minus 3 times 2x cubed plus 5x, and then derivative of that part will be 6x minus 1 over 3x squared minus x squared. So you can do this way too. Or you can do the third way by simplifying first, okay? So it's up to you. Now, they look different, right? So here, the first term and this one, they look different. But actually, if you simplify, they will be the same. Okay, guys, if you don't have any questions so far, then what we would like to do in the next segment of this lecture is that we want to apply this skill to solve some real world problems. After all, we do all these mathematics because we can apply this maths to solve real world problems, right? That's the goal. So especially for us, business and economics and social science. So there are few terms often arises in business and economics, which is cost function, cost, revenue, profit, demand, price, those types of terms. So here, let us define few terms from economics. If CFX is the cost of producing X items, then the average cost of producing X item is, the average means total cost divided by number of items, right? Always, we know from elementary school that average is always the sum, okay, sum total divided by total number of items, total sum divided by total number of items. So that's the simple formula that we have been, we learn in elementary school. So the same thing, total cost is C of X, then the average cost will be total cost divided by number of item, which is X. Please keep that in mind. By the same token, if total revenue is given by R of X, then the average revenue will be R of X over X. And if P of X is the total profit, then the average profit will be given by P of X over X. I just want to remind you one thing, that in general in this course, the capital P, the uppercase P, will be using that for profit, and the lowercase p will be using that for price. Okay, just keep that in mind. Now here is example 3. Total, the cost of producing X bicycle is given by CFX equals 0.2X plus $5,000. Find the average cost per bicycle. I will add one question here. Also find fixed cost. Okay, let me add this question. Now, part A, average cost. Average cost is pretty simple. Total cost divided by number of items. Total cost is given to be C of X divided by number of item is X, which is 0.2X plus 5 over X. That's going to give me, yeah, you can leave it there like that. Now, the second part tells us also find the cost, fixed cost. So fixed cost is the cost when no item is produced, right? That is the fixed cost. I think you guys already know this. So therefore C of 0, so your fixed cost will be C of 0, which is cost function 0.20 plus 5, which is 5. It is 1,000, so $5,000. Okay, that is the fixed cost. Now let's move to part B. Evaluate the average cost when X equals 50 and interpret the answer. Evaluate the average cost when X is 50. So when X is 50, average cost equals 0.2 times 50 plus 5 over 50. And how much is that? I believe this is 0.3. And since the unit is 1,000, 0.3 thousands. How much is that? 0.3 thousand means. Because in general, in the real world, we don't say, if somebody asks you, then how much money do you have? You don't say $0.3 thousand. You rather say $300, right? So yeah, mathematically this is correct. 0.3 is correct, but we are talking about the real world application, and we don't say that I have $0.3 thousand. So you better change it into, into acceptable form of dollar amount. Okay, now part C. Find the marginal average cost. So let me copy the average cost first. Okay, we have average cost. I'll write, AC like that, okay? Average cost, A sub C x equals 0.2x plus 5 over x. I'll represent this average cost by A sub Cx because A represents average cost function of x, okay? So this one, now marginal average cost, marginal average cost. We know that marginal means derivative, so we just need to find the derivative of this. So you see, this one is again u over v form, quotient rule. So we know the formula uv plus not plus, minus here, uv minus uv over v squared. So that is the formula, we know this, quotient rule. So we just now use this formula. So u prime giving me u prime is 0.2 and copy v, which is 5. Sorry, x minus copy v, 0.2x plus 5, and then derivative of v, which is 1, over v squared, which is x squared. So this is gonna give me, if you simplify it, you will get, is that minus 5 over x squared? I want to check this answer with you guys. So did you get the same thing? Okay. All right. So part C is done. What we have to do now? You see part D, it says that evaluate the marginal average cost when x equals 50 and interpret the answer. So part D, we need to evaluate when x equals 50. So when x equals 50, your marginal average cost. Marginal average cost equals A sub C prime of 50, which means negative 50 over 50 square. That's going to give you negative 0.002. What does this mean? So because we found the marginal average cost to be negative $2, so what it means is, if you want to write this in a nice word, the meaning would be when 50 bicycles are manufactured, the average cost per additional bicycle is decreasing by $2. Does that make sense? Even though the total cost will be rising, I agree with that, okay? Total cost will be rising, will be increasing, but the average cost per bicycle will decrease. So that is the idea. And I think you deserve this. Example 4 is very similar to this, and I leave it to you. The solution will be provided there just in case if you need, but it's the same concept. I trust that you can do it. I think you deserve 10-minute break, guys.